Consider the quartic polynomial given here. We're given that p of 2 plus 4i equals 0. Determine a quadratic factor of p of z. Well, we know that p of 2 minus 4i will also be equal to 0. Therefore, z minus 2 plus 4i, z minus 2 minus 4i must be a factor. Now, if we expand that out, we get z squared minus 4z plus, it's just going to be 2 squared plus 4 squared, making use of dots and the fact that I squared is -1, and so that will be 20. Hence we want to solve the equation. So we know that z squared minus 4z plus 20 is a factor. We must be able to find another quadratic factor since this is a quartic. Now it's going to start z squared, so that when we expand out, z squared times z squared gives me z to the 4. With a plus 20 at this end and a plus 60 here, it means that this end has to be plus 3. I'm not quite sure what's going in the middle, so I'm going to call it a z. But then let's look maybe at the z cubed coefficient. So here that is -6. Well, it's going to give us z cubed. So when we expand out here, this times this would give me z cubed. So that would be a z cubed. And I'll also get a z cubed from here. It would be minus 4 z cubed. And those are the only ones that are going to give me z cubes. It therefore follows that a is equal to -2. So we have z squared minus 4z plus 20, z squared minus 2z plus 3 is equal to 0. We already know the solutions that come from here. We're now after the solutions that come from here. So let's use the quadratic formula. So z would be 2 plus or minus the square root of 4 minus 4 times 1 times 3 all over 2. So that's 2 plus or minus the square root of 4 take away 12. And of course, root 8 is root 4 root 2, which is 2 root 2. So that is going to be 2 plus or minus 2 root 2 I over 2, which is 1 plus or minus root 2 I. And so my solutions are 2 plus or minus 4i and 1 plus or minus root 2i.